Good morning everyone. My name is Ravicharan from Mechanical Department in SRIT College and I am here to give the presentation of extrinsic semiconductors. Extrinsic semiconductors. Introduction to extrinsic semiconductors. Extrinsic semiconductors are materials doped with impurities to exchange their electrical properties. They are essential for creating semiconductors with specific conductivity types. Understanding their behavior is crucial for designing electronic devices such as diodes and transistors. They are essential for creating semiconductors with specific conductivity types. What are semiconductors? Semiconductors are materials with electrical conductivity between conductors and insulators. Silicon and germanium are the most common semiconductor materials. Their conductivity can be modified by adding impurities, making them versatile for electronic applications. Doping and its significance. Doping involves introduction impurities atoms into the semiconductor crystal lattice. Their process alerts the number of charge carriers, thus changing the material conductivity. Doping is fundamental in controlling the electrical characteristics of semiconductors. Their process lateral the number of charge carriers, thus as changing the material conductivity. Types of extrinsic semiconductors. There are two main types of semiconductors, N-type semiconductor and P-type semiconductors. N-type semiconductors are doped with elements that provide extra electrons and P-type semiconductors are doped with elements to create holes or positive charge carriers. N-type semiconductors. Doping with elements like phosphorus or arsenic adds free electrons to the crystal. Electrons are the majority charge carriers in N-type semiconductors. These materials exhibit increased electrical conductivity due to additional electrons. Electrons are the majority charge carriers in N-type semiconductors. P-type semiconductors. Doping with elements like boron or gallium create holes or positive charge carriers. Holes are the majority carriers in P-type semiconductors. They facilitate current flow when electrons move to fill these holes. Formation of PN junction diode. When P-type semiconductor and N-type semiconductor materials are joined, a P-type PN junction diode is formed. This junction is crucial for diodes, transistors, and other semiconductor devices. The PN junction exhibits rectifying behavior, allowing current to flow in one direction. Electrical behavior of extrinsic semiconductors. Extrinsic semiconductors have higher conductivity compared to intrinsic ones. The dominant charge carriers, electrons or holes, determine the semiconductor behavior. Temperature and doping concentration influence their conductivity and device performance. The dominant charge carriers, electrons or holes, determine the semiconductor's behavior. Applications of extrinsic semiconductors. They are used extensively in electronic components like diodes, transistors, and solar cells. Doped semiconductors, enabling the manufacturing of intrinsic circuits and microprocessors. Their adjustable properties make them virtual for modern electronic and optoelectronic devices. Doped semiconductors enable the manufacturing of integrated circuits and microprocessors. They are used extensively in electronic components like diodes, transistors, and solar electric. Their adjustable properties make them virtual for modern electric and optoelectric devices. Summary and conclusion. Extrinsic semiconductors are essential for controlling electrical properties in electronic devices. Doping introduction and impurities atoms that modify conductivity and charge carrier types. Advances in doping techniques continue to drive innovation in semiconductor technology. Thank you everyone, and I am glad to give the presentation in external semiconductors. Thank you.